Uh, so I'll try to be quick because we have 20 minutes to do this thing. So this talk will be about productionizing H2O models using Apache Spark. I'm Kuba. I work in H2O. I'm a software engineer there on the Spark Motor project. Why I mentioned two people. Other guy who is also mentioned is Michal Mohlava. He's currently our VP of engineering. And without him, Spark Motor wouldn't exist because he wrote the basics back then. So let's get to more interesting things. What I would like to cover today is the whole machine learning lifecycle and how we tackle that inside of H2O and Spark Motor environment. So these following slides, like 3 of those, will be a little bit more abstract. And we will cover how the general machine learning lifecycle looks like. So usually you have to do, maybe I will repeat myself, or you already know that, maybe we first need to do some data engineering. It can be in any platform you want. Right now I'm abstracting that from any particular platforms, just abstract boxes. So you prepare your data in order to be able to train a model on them. Before you train a model, you usually want to do some feature engineering to get the best model out of the data you have. This can be also iterative process in the same way as the model training itself can be also iterative process. It can be AutoML, it can be, you can use stack ensembles, whatever modeling technique fits your needs. And then you become to have some model, which you want to actually deploy to production. So the fun isn't over. We need to do something with this model. So usually what we have is some streaming data with that X down there, and they are coming as input to our pipeline. And we need to do the feature transformations on that streaming data as well, because we need to ensure that the input to that streaming into our model is actually the same as it was during the training. So we do the featureization, and then we also apply the scoring method or predict method inside of the model. And again, this can be Spark, this can be H2O, this can be your custom prediction pipeline written in Java or any other language. This is still abstract. And what we are going to cover today is our 2 implementations of this machine learning lifecycle. The first one is about using Spark Motor and H2O. So we will use Spark for both data engineering and feature engineering, and H2O for model training. And the type pipeline the code which we will use for deployment will be Spark, and the model will be H2O Mojo. You probably heard something about H2O Mojos already. So just a quick recap. H2O Mojos are a way how we store information about the model. So it's a structure which contains metadata about the model, and we provide several wrappers for Python and Java, which can actually read that Mojo and run, let's say, a predict method using that Mojo with the information about the model. And the second implementation I'm going to show here is using driverless AI as the backend for feature engineering and training and modeling techniques. But again, we will use Spark Motor and Spark as the backend and as a backend for the deployment. In this case, we will use the driverless AI Mojo, which is similar to the original Mojo, except the original Mojo is just one step, and that is used for the scoring. The driverless AI Mojo has also additional steps, which actually tell us how to do the feature engineering, because we need to ensure that we apply the feature engineering before we run the scoring. So how does it look in Spark Motor? Spark Motor is one of our products. It's an open source product, and it integrates H2O free, which is directed by Michal Kurka, and Spark. So what are the advantages of using this combination? We have a H2O, which is a machine learning library. We have all the algorithms distributed. We think that we are pretty fast and accurate. And what is actually important to say that at some aspects, H2O might be targeted to machine learning experts. We of course have AutoML, which makes it way easier for people. You just do AutoML and it will train your model. But in case we talk about normal algorithms like GBM or deep learning, if you want to make the best out of your data, you maybe need to configure the models. You need to know about data science to be able to get the best. So this tool might be for experts. What Spark Composer is doing here is that it's just combining the H2O and Spark world. For example, Spark has powerful data munging, H2O has powerful machine learning capabilities. So we join them together inside of one tool. What we also try to do here is to be transparent for Spark users. What it means that we try to be consistent with the Spark APIs. We try to play nice with Spark, so people don't have to learn how H2O does things, but they need to know how Spark API looks like. And it's this example will be heavily showed on the Spark pipelines, because we think that this is a really nice way how to work with the models, how to work with the transformations, and how to deploy them. So the example implementation in this case with Spark Composer looks like this. We can see 3 boxes. The orange box at the beginning means that we will do data cleansing and feature engineering in Spark. And because Spark Composer integrates those 2 environments, we can seamlessly switch to H2O side in one cluster and do modeling inside of H2O. So we use H2O for the model training. And once we have the model, once we basically created a model in offline environment, we can put it into production. And we can take the same pipeline we created during the offline training, and we can apply that during the fitting process in streaming application. So we have just one artifact. We can apply both in the offline time and online time. And for the streaming pipeline, we again use Apache Spark as a deployment tool where we just run that pipeline we created. In the deployment, we don't have to have H2O running. Once we have the Mojo, you don't have to have H2O cluster running. You just need to have the wrapper which actually understands that Mojo and can read that and can provide, let's say, the predict method. So this was a little bit more abstract. Let me show you a really quick demo what I mean by training the model offline with pipelines. This is a Jupyter notebook I prepared. I will just make sure that Spark is ready, that PySparkling is ready, which is our Python for Spark Composer in Python. I will start it. I will start H2O context, which will actually start H2O on the one executor I have here. So we have it running. And I'm going to define myself a really super tiny pipeline, which has 2 stages. The first stage is provided by Spark, and it's a feature transformation. It's really simple transformation where I'm just filtering specific rows. The second transformation is actually estimator, and it's used to run H2O AutoML algorithm. So I define myself these 2 stages, and I can create a pipeline. So still, I haven't run any code. I just define the stages in beforehand. And I can load the data, and I can, I need to, because Spark pipelines actually accept Spark data frames. So I need to convert first the H2O frame to Spark data frame, and then finally I can put it on the input of the model. I still haven't mentioned what data set we are working on. It's not really critical in this case, in what I'm trying to show, but it's a data set which is provided by driverless AI, our internal runs, and we measure how long driverless AI ran, given, for example, how many features were there if we did use CPU or GPU. And what we are trying to predict here, how long driverless AI runs when we have this data provided. So right now what it's doing, it's running AutoML inside of Apache Spark, which I just defined here. I specified 60 seconds, so it will run for 1 minute. It will try to give me the best model within these given constraints. This is, as we already said, this is open source. AutoML is open source, so you can also try it at home. What I also did here, just some technical options seed, which is for reproducibility. And if I hit some unknown categoricals during the scoring time, I don't want to die. I just want to handle that as NAs, not a number. So I have the model here. I will just store the pipeline on this, and I can also do some example transformation, which actually runs the prediction. So I can see that on these two rows, I just outputted. I have the prediction output with prediction with the predicted value. So that's one way how to do the offline training. Also, yes, here. So that was the demo for the first implementation. At the end, I will show you how to actually put this into deployment. Right now, I'm still showing how to create these pipelines. So other way how we can actually tackle a very similar issue is using H2O driverless AI and Spark. So what driverless AI, you probably heard a lot about driverless AI, so I'll be concise. In comparison to H2O, driverless AI helps if you don't have the core knowledge of machine learning. If you don't have all the knowledge about the algorithm, all the options you need to set to specific algorithms, the driverless AI can help in this case. So it's not for machine. It might not be exclusively for machine learning experts. And what is also nice about that we also provide automatic feature engineering, which is provided by our internal knowledge, which we gather from our Kaggle grandmasters. So they help us a lot, and they create recipes inside of driverless AI, so we can do the feature engineering and take the best of your data. How this the abstract lifecycle looks like, how this lifecycle looks like in terms of driverless AI. So we just see that we use Spark just for data preparation right now. And we use driverless AI for both feature engineering, training the model. And again, for the deployment, we can use the same Spark pipeline, which we create from the offline training, and put it in a production, again, on Apache Spark. The pipelines have the same APIs, so if you use the H2O free pipeline with H2O free or pipeline with driverless AI, the API is actually the same. So this is actually interchangeable. You can decide if you want to use H2O or driverless AI. You can replace that. So I'm just gonna quickly show. You probably saw driverless AI thousands of times, but I'm just gonna start it, and maybe if it finishes, but it's not critical. We want to predict the total time, how long driverless AI actually runs. And I can just give it a really small amount of time. And when this finishes, you can actually download the Mojo, which actually represents the model itself. And that's it for the driverless AI demo. Because once you download the Mojo, you can again load it into Spark pipeline and put it on deployment. There is no other artifact you need for this, just this Mojo, which you download once this process finishes. This is just for safety purposes if I don't have internet access. What this slide says, actually, it's about what driverless AI is doing for us when it comes to feature engineering. On the right picture, you can actually see that there is still thousands of interactions, which actually we as humans can't even. It's not manageable by one human brain, and maybe not even more people. So this is what this tool does for us. We can actually it can work with the input features, and it can create even thousands of additional features which can make your model better. What is also a little bit side note, I just covered the basic machine learning lifecycle. I'll create model and I'll put it into production, but that's not everything. We have also additional things we would like to perform during the lifecycle. We, for example, would like to do auto documentation, which you saw during the Strees keynote in the morning in terms of driverless AI. Because we can actually document the model, the methods we used automatically. We don't need to use people to write it manually. That's just waste of time. What we can also do is the model management. What I mean by that once you train the model, you could actually store it to some database or some even more smarter storage. You could do some searches over the models you train according to some matrices. And it's, again, good for reproducibility. You just train several models, and you just want to find in the history which model was the best. And what we are also working on in H2O is the model monitoring. And what that means is that once you put the model into deployment, it might be beneficial to monitor the model behavior. What I mean by that is, for example, if you have simple binomial model with some distribution, maybe 60 to 40%, and you're in the streaming environment, the distribution changes, you probably want to capture this change in the environment and either retrain a model or do something with it. So, and again, we can automatize this because it's possible to write it, and we are actually working on a solution for this issue in H2O. And before we wrap it up, would like to show you how we can actually productionalize. This will be in Shell. How can actually productionalize this thing in Apache Spark. I'll just run this code and I will show you the simple script once this finishes. What it's actually doing, it will load both the Spark pipeline, the pipeline with H2O free model, the Spark pipeline with driverless AI model. It will load them into memory. It will start reading data from S3 bucket. It will apply the pipelines to the data in the S3 bucket, and it will run the predictions. And I can see the data predicted by Spark and by driverless AI. The outputs are similar. It's like you just need to believe me what the number says. I'm not trying to compare the results. I'm just trying to show that it's easy to deploy. And how does the script look like? So this will be one little bit more technical minute. Score both pipelines, the py. So this is just like a few imports I need to do. Here I'm starting a Spark context for me, or Spark session. This is just technical call, which actually puts our jar on the Python path, so it understands that. We are not starting H2O context. We are not starting H2O because in the time of deployment, we don't need that. Here I'm loading the pipeline created by H2O free, and here I'm loading the pipeline from the H2O driverless AI. And these Mojo 1 and Mojo 2 actually have the same APIs. So once you load it using these two different methods, you have the same APIs you can work with. I'm specifying here the schema because when I want to work with the streaming data set, I need to specify the schema. You can also specify the schema using JSON files based on your training data, so you don't have to actually create it manually. But for this purposes of this demo, I just typed it here. And here you can see I'm just specifying the input data stream, which is the S3 bucket with our data, where the CSV files are being stored every minute, every second. And I'm creating two output data streams. The first one is based on the Mojo from Spark, the second one on Mojo from driverless AI. And I just start those. This is just simple helper method which actually turns the number to human readable time. And that's it. This just shows the data into console. So actually what I just need to do to deploy these pipelines is these 3 lines of code for each of the pipeline. Create the input data stream, call the transfer method, and start the output stream. Let me go back to slides. And that was, in a really fast way, everything from me. There is additional information behind this QR code on this link. So you can take a picture of it. It will take you to a page with additional links. It's also here. So the final note I want to say is that Sparkling Water is not just a tool where you can run machine learning H2O models, but you can also use that tool to deploy our models from other different tools like driverless AI, H2O free. So we think of Sparkling Motor as an enabler of these models as well. Yes. That QR code on the last page should be also the same. But I have 3 or 2 minutes to take your questions. If you can talk to the mic, please, that would be better, so we can hear your question.
Is this actually? If you guys could just put your questions into Slido,
yeah,
that would be
Slido.
ideal. So sli.do and use the event code H2O world with a £, and the room is right in front of you. Tibshirani Hawking. Thank you. There are actually a couple already there.
Okay.
Oh, you don't. Oh, okay. Never mind. I got it. Okay. Sorry about that. So it seems that there is no Slido operator at the moment, but I have the Slido questions, so I'll be asking them.
Perfect.
So first question, does sparkling water provide APIs for feature engineering, and do you do it yourself or, with the Spark framework?
So sparkling water does provide methods for feature engineering, but they are provided by Spark. That's the power of sparkling water. We do not have. We are trying to catch up, but right now we don't have such an extensive power in H2O. So we are using Spark for these transformations.
Second question, can the Mojos be deployed directly into apps and dashboards?
You can deploy Mojo basically anywhere you want. It just depends in which tool you want to deploy it. Here I use Apache Spark because it's really simple to do. You can also deploy it on a bare metal. You can write yourself your own Java prediction system where you can just plug your Mojo and run your predictions.
And the last question that we have right now, with respect to model management, becomes a bit difficult with the changing versions of Spark, H2O, and sparkling water. Do you have any suggestions on how to manage this beyond virtual environments or Docker? Right now, we don't have like any solution for that, but the Mojos are actually very like backwards compatible. And the Spark pipelines themselves as well. So across the like versions for like minor versions of Spark, and the Mojos are compatible across all the H2O versions. So if you use H2O Mojos, you don't need to worry about versions actually. If you use Spark, you just need to worry about like major version of Spark, and they tend to break the APIs very. They will announce that if you should know about that if they will break the API. They also try to be backwards compatible as long as it's possible. And okay.
I'm out of time, so thank you for all the questions. If you have any other questions, please catch me later, and thank you for staying here.